This is Akashvani. In the program Spotlight, now we bring you a discussion on recent cabinet decisions regarding the space sector. The participants are Dr. T.V. Venkateshwaran, Senior Scientist, Vigyan Prasar, and Ramya, Anchor.
The Union Cabinet on Wednesday approved 4 big-ticket space projects, including the next mission to the Moon, a mission to the planet Venus, follow-ups to the ongoing Gaganyaan mission, and the setting up of an Indian space station, and the development of New Generation Launch Vehicle, NGLV. Doctor, the recent announcement about the Venus Orbiter mission, also being called Shukrayaan-1, came as a pleasant surprise. What are we expecting to learn about Venus from this mission?
This Venus Orbiter mission, VOM, that's what it officially is called, is to reveal to us some of the greatest mysteries of planet Venus. What are those mysteries? One of them is, it is the hottest planet in our solar system. Though it is not nearest to the sun, though it is the second planet from sun, it is the hottest. Why it is hottest? Because it's always covered by clouds. What are these clouds? These clouds don't carry water, but largely carry sulfuric acid. So because of this thick cloud, the Venus is experiencing equivalent to what we can call as global warming. We can call it as planetary warming. So how this planetary warming took place, why it is persisting, these are some of the important questions that we need to understand. We need to understand this to understand planet Venus. And by understanding planet Venus, we can actually also understand much deeply about our planet Earth. What kind of changes can happen at the global level on Earth? This is a question that we are faced with, because this is an existential question. If the planet continues to heat up, the Earth continues to heat up, it will become inhabitable for humans, right? So even our own self-interest requires us to understand planets near us so that we can manage our planet.
So, Doctor, as you mentioned, despite being called Earth's twin in its size, Venus's atmosphere has been known to be the hottest among all the planets, with its surface being made of only carbon dioxide and shrouded by clouds of sulfuric acid. So how do we plan to send an orbiter that will endure all this and yet give valuable information about Venus back to the Earth?
Actually, there are two kinds of challenges in sending mission to the Venus. One is launching can happen only once in 8 years. The window for reaching Venus comes only once in 8 years. The next window is on 2031. It's actually like when you launch your rocket in a particular direction, in that particular direction, the Venus has to come when your rocket will go into that point in the orbit of Venus. So taking all these dynamics together, if you want to get there with the least fuel expenditure, so then there are windows, not only for Venus, for every planet, even Moon, everything has a window. So you can launch only on those windows. You can't launch on any day. You can't say that today I like it, so let me go to Venus. You can't do that. So these launch windows are there for every planet. This planet has once in 8 years. Mars has once in 4 years. That's the difference. So you are in 2031. Second, if you are going to orbit the Venus, one time you will be in the shadow of Venus, one time you will be exposed to the sun when the orbiter goes around the Venus. So when it is exposed towards the sun, it will be very hot. And when it comes to the shadow, it will suddenly become too cold. That is something like from minus 200 to plus 200. That's the kind of variation you might have. So you need to maintain the spacecraft temperature, which is going to be one big tough job. So given all these things, launching a mission to Venus is considered as more tougher than going to Moon and Mars. That's a big challenge that ISRO is willing to take.
How do we plan to make the appropriate materials for the spacecraft so that it doesn't get damaged in the middle of the mission?
Basically, you'll need some cooling system, you'll need some radiator system which will radiate excellent and also will not become too cold when it is too cold. So these are all the satellite designs, that the spacecraft design that one has to undertake when this mission is being developed. So these will be done by ISRO, including the launch path. See, initially you will be putting it in a very huge elliptical orbit because that will be the easiest thing to do. And then you will have to slowly aerobrake and then bring it to the orbit which will be adequate to study the Venus. I mean, you can't study it from very far. So you have to come closer. So for that closing in, you'll have to create certain flight paths. These are all the challenging work that ISRO will undertake. And the research institutions in India will develop equipment, scientific equipment, which can study Venus and why it is so hot and things of that kind, so that we can understand the dynamics that is there in the Venus, which is making it the hottest planet in the solar system.
So, since you told our listeners just a few minutes ago that it is tougher to send an orbiter to Venus than to Mars or Moon, so how are we planning to first have certain simulations to test whether the orbiter will be able to withstand such temperatures? How long do you think it will take for us to actually send an orbiter to Venus?
So latest that you can plan is 2031, which is just about 5 to 6 years. If we actually put it on a speed mode, maybe that is possible. If not, we'll have to wait for another 8 years. So number of factors will come into play when you can launch. It's not only the launch vehicle, it's not only satellite, it's also your instrument. You are not just going to send a spacecraft. The instrument has to work. Instrument will have to be calibrated. It has to work perfectly and then should give you proper data. So all this testing, etc. will be done. So multiple institutions will be involved, and obviously ISRO will test the material for this. In fact, in ISRO there is a facility called as thermovac. Thermovac meaning thermal vacuum. So it's a kind of a huge cavity where you can simulate space-like conditions. So any material that you are going to send to space, you can keep it inside and test whether that material, that instrument, that gadget, that electronics will work in space-like conditions. So ISRO has that facility, and quite obviously it will use that facility to test the Venus orbiter mission components and satellite too.
So how will studying about Venus help the Earth when it comes to its own atmosphere?
See, what is happening in Venus is not a localized phenomena. It's a global phenomena. So this global phenomena, how it got triggered, how it is sustaining globally for such a long time. Millions of years, it's very hot. So how it is sustaining for that long time. How did this actually occur there? What triggered it? What is sustaining it? This kind of understanding will tell us that what kind of threat is there for Earth. We know something. We know that we don't know something. But then there are something called as unknown unknowns. If you want to know unknown unknowns, it's only by studying other planets which go through such phases which we can call as disaster from our point of view. Only by knowing that, we will know what are the unknown unknowns. So we can make the unknown unknowns into a known unknown, and then we can study it, we can understand it. So Venus will be an object lesson to understand the planetary sciences about Earth.
So Doctor, moving from Venus to the more familiar Moon, talk to us about the Chandrayaan-4 mission. What are the objectives of this mission?
So if you look at the missions to Moon, usually there are 3 kinds of missions to Moon. Not only Moon, any planetary object we can say, or celestial object we can say. The first attempt usually will be orbiter. So you fly a spacecraft, it will go near that celestial object, it will go around in an orbit. From a distance, using remote sensing, it will study that planet. So we have done that with Chandrayaan-1. Then the second mission will be usually a lander, and with a probe like rover. Okay, so that's what we tried in Chandrayaan-2, partially succeeded, but then completely succeeded in Chandrayaan-3. We landed on the Moon, our rover worked there for 1 lunar day, we were able to collect data. The third step, usually all the spacefaring nations do when it comes to planetary study, is sample return. You land, collect sample, and bring it back to Earth. Why, you might say that, why do we need this one by one? So let's look at it this way. So when we send Chandrayaan-1, it is going around Moon for so many years. It has mineralogy mapper. So using remote sensing, it is mapping what minerals are found on the surface of Moon from a distance, from 100 kilometers away. But how can you be very sure that is what is there? You need some more proof, right, to trust that data. So when you land and when you send a rover, and the rover goes around some 100 meters, tests the ground using the probes, and then detects the material. And if that matches with your Chandrayaan-1 data, then your trust on that data becomes even stronger. Now, with the lander, you got some data, you got some speculations, you have some idea. So if you bring back sample and on Earth we do more studies, then we will have a much better trust on the data. Or we will know that how to change that data so that the data will reflect the truth. This is called as ground truthing. So this ground truthing is what will happen in these missions.
So, Doctor, Chandrayaan-3 was a milestone for India, and during the Chandrayaan-4 mission, we are planning to bring back samples from the Moon. How will we be able to monitor the rover on the Moon? Will we be relying on artificial intelligence, or will the scientists from the ground level here be controlling the rover which is there on the Moon?
This time in Chandrayaan-4, there will be no rover. This Chandrayaan-4 will have 4 modules. See, Chandrayaan-1 had only one module, which is orbiter. Chandrayaan-3 had 2 modules. One propulsion module, which went around the moon, and then a lander module, which landed on the moon. Now, the Chandrayaan-4 will have 4 modules. So, there will be one module, which will take your spacecraft to the moon. There will be a second module, which will land on the moon. There will be a third module which will detach itself from the second module and then, like a rocket, launch from the moon and come to the upper layers of the moon. And then there will be a fourth module which will collect the sample from the third module and land on the Earth. So there will be 4 modules. So these 4 modules are going to be launched through 2 spacecraft. One spacecraft will take 2 of them, the other spacecraft will take 2 of them. That's how it's being planned right now. 2 LVM rockets are being thought of. So this is what it is. So there will be no rover. You will land in one place, there will be a robotic arm which will collect the soil samples, rock samples, and then put it into a canister. So that canister will come to the about 100 kilometers above the moon through an ascent module. The canister will be then transferred from that ascent module to the lander module we will have. So this lander module will land on Earth using parachute. That's the idea. So inside that lander module, in a canister, you will have the soil sample, rock sample from moon. And ISRO is also planning to establish an institution to study these materials, like interinstitutional one arrangement ISRO is hoping to establish. So we will have a better understanding of moon plus our data. How far we can trust our data, we'll be able to get from this.
Doctor, our listeners are also very excited about India's first human space flight mission, Gaganyaan, as the cabinet recently approved the building of India's very own space station, Bharatiya Antariksh Station. Please tell us more about it.
So this again, any nation which has sent a human being to space, to orbit, will follow it up by a space station. Soviet Union sent first the human being Yuri Gagarin, and it followed up with a space station called Salyut. It's a very small station, Salyut. Similarly, the US, when it sent its astronaut to the space, it followed it up with a space station. China has already done it. Today, if you look at it, there is a Chinese space station and then there is an international space station in which the Russia and America are collaborating. So the idea that India is saying is that we cannot have a one-off Gaganyaan. It should have a natural follow-up. The natural follow-up is setting up a space station. So why do you need a space station? If the Gaganyaan 1, for example, is going to take a person, make 16 times orbit around the Earth for a day, and then come back. That's a demonstration. That's a proof of concept. That's all. It's like a test ride. You want to buy a car, you go to a shop and then you take the car, do a small drive and then come back and park. But that's not the end of it, right? So you need to use that technology for some useful purpose. So the space station provides you to conduct experiments, develop technologies, test your technology and so on. Maybe I'll give a simple example which will maybe make us understand. Suppose you want to make an alloy using 2 metals. Here you will melt the metal, you mix them. But when you mix, even if you mix very well, because of the Earth's gravity, the metal which is heavier will be in the bottom and the lighter will be on the top and the mixing will not be even. But in a space station, there will be no such, it's called as microgravity, it's called actually free fall. So in that free fall situation, you can have a very even mixture of 2 materials. This kind of advanced materials are needed for chip making, for various other products, advanced technological products. And then the space station can provide you such a platform for working on this, designing on this, developing technologies.
Thank you so much, Doctor, for enlightening our listeners about the various space missions that have been approved by the Union Cabinet. We hope that in the coming years, in terms of space missions, India, in the words of Rakesh Sharma, does prove to be Sare Jahan se Acha. Thank you, Doctor, for joining us.
Thank you very much.
You were listening to a discussion on recent cabinet decisions regarding the space sector. The participants were Dr. T.V. Venkateshwaran, Senior Scientist, Vigyan Prasad, and Ramya, Anchor. This program was produced and presented by the News Services Division of Akashvani. You can listen to it on our mobile app, News on AIR. This program is also available on our YouTube channel, News on AIR Official. You may share your feedback about this program through email at airnsttalks@gmail.com or WhatsApp on 9289094044.